Solving quadratic equations. Which method is best? So now that we know multiple methods to solve quadratic or degree 2 equations, the question that you might be asking at this point is, how do you know when to use what method? Well, first let's review these methods. So again, this is focusing on degree 2 equations or quadratic equations. We've learned 3 methods. The first method that we have learned is the factoring method. Now this method not only works for degree 2 or quadratic equations, this method works for any type of polynomial equation, of course, as long as it factors. Our second method is the square root method. Now this one works only if there is a single x squared variable, meaning there is no x variable involved. Our third method is the quadratic formula method. And as long as your equation is a quadratic or a degree 2 equation, your quadratic formula will always work. So now we see our 3 methods here. We want to know when is it best to use each of these methods. So we can see that each of these methods has their own stipulation for each of them to work. The factoring method. Our stipulation here is that our polynomial must factor. The square root method. The stipulation here is that there can only be an x squared or no x term involved. The quadratic formula, it must be a quadratic or degree 2 equation. So each of them has their own criteria to figure out if each of those methods work. But last time I gave you an example that was c squared minus 25 equal to 0. And we solved this example using all 3 of these methods because it fits the criteria of all 3 of these methods. It factored, there was a single x squared or c squared variable with no x involved, and it was a degree 2, meaning the quadratic formula worked. So if that's the case where all 3 or maybe just 2 of the methods work for each of these problems, which method is the best method to use? And the answer to that question depends upon you. It depends upon what method that you favor. Now I'm going to tell you what I favor, but that might be different than your personal preference. So if you do it a different way than the way that I do it, it does not mean that it's wrong by any means. It just means that we have different personal preference. So at this point, I'm going to tell you what my personal preference is, and I'm going to explain why. But if you like to do something different, then go for it. If I have a choice between all of my methods, the first method that I'm going to try and do is the square root method. Now, remember this method has the square root property. It says, if you're going to force in a square root, then you must also force in a positive and a negative to go along with it. If you have difficulty remembering that property, then maybe the square root method is not for you. Also, I want to point out that this method does not work very often. For this method to work, we have to be missing the middle x term. And in most of our examples, that does not fit the bill. So most of the time we will not be able to use the square root method. If I can't use that method, then my next choice is to use the factoring method. And the reason that I like to go to the factoring method next is because I am very comfortable with factoring. It does not usually take me very long to factor a problem. I can figure it out within 1 or 2 steps quite often. Again, if you are not comfortable with factoring, if factoring takes you a very long time to do, then maybe the factoring method isn't for you. At this time, I'd like to point out that if you can solve a problem using the factoring method, that you should end up with what I like to call as nice or pretty answers. Now, what I mean by nice or pretty answers is I mean that your answers are going to end up as rational answers. And if you have a hard time remembering what rational means, again, look at those first few letters. It spells out ratio. So either these answers are going to end up as fractions, or they can also end up as whole numbers. The other two properties have also the option to end up as rational answers, but they also have the option to end up as imaginary, or answers with I in them, or answers with square roots in them. Now, if neither the square root method nor the factoring method works, then I go to my last option, which is the quadratic formula. Now, the reason that I like to keep the quadratic formula as my last option is because, hopefully you saw in the last few videos, that it is a very lengthy formula. It takes us quite a few steps to get from start to finish. So you can see that my personal preference is always to try and do the shortest method first and the longest method last. If that doesn't seem to be an issue for you, then I would use the one that becomes the easiest to you. So if you always want to use the quadratic formula, then go for it. There is no issues with starting with that method as your first method. So I have a few examples here, and I want you to try and figure out what's the best method for you, and then to solve your equation utilizing that method. So my first example here is 2 times v minus 3 quantity squared plus 90 equal to 0. And at this point, you should try and pause the video and see which of those methods work best for you, and then solve the example using that method. If you would like to check your answer, it's at the top right-hand corner of the screen. Okay, the method that I am going to use on this one is, I always like to start with my square root method. So I'm going to try and do that here. Now, it doesn't look like your typical square root method. We do not see a x squared term involved initially, but it is actually there in a roundabout way. I have a v and I have a squared. So I do actually have the v squared here with no extra v or single v involved. So I can solve this one by utilizing my square root method. If you would like, try and pause the video using that method. Okay, the method here first says we have to isolate our square. So we have to isolate the parentheses with the square around it, which means I have to get rid of this 2 and this 90. And I should always do it in reverse PEMDAS order, meaning I should subtract 90 from both sides first. That leaves me with 2 times v minus 3 quantity squared is equal to negative 90. Again, trying to isolate my quantity squared, I need to get rid of my 2. Since it is multiplied by this, I need to divide by 2 on both sides. And that leaves me with v minus 3 quantity squared is equal to negative 45. Now, since I have my square isolated, I do my opposite operation to get rid of it, meaning I force in a square root. But the square root property says if you force in a square root, you should also force in a plus and a minus. So on the left, my square and my square root cancels out, leaving me with v minus 3. And on the right, I have plus or minus square root of negative 45. Now that does not come out evenly, but I can actually simplify it using my good pi and my bad pi method. My good pi here, I want to divide 45 by a square, and the largest square that goes in evenly to it is a 9. Not only 9 goes in my good pi, but we've learned how to take the square root of a negative, so a negative also goes in my good pi. And negative 9 times a positive 5 gives me 45. So my bad pi here is the leftovers are just the 5. Now let me simplify this here. Carrying down the rest of the problem, I have v minus 3 equals plus or minus. The square root of negative 9 is 3i. And then my square root of 5. My last step in this problem is to isolate my v variable, and I do that by adding 3 to both sides of the equation. That leaves me with v is equal to positive 3 plus or minus 3I square root of 5. Or if the problem asks for the solution set, then that would be the same answers in the braces of this problem. So you can see that this method is solvable by using the square root method. If we look at our answers here, our answer does include an I and a square root of 5 in it, so you could have not solved this by using the factoring method. Those are not pretty answers. However, you could have solved this by using the quadratic formula. Now I'm going to start this one using the quadratic formula method, but I'm not going to finish it, and the only reason that I am starting it this way is because if this was your method of preference, I want to get you going on the right track. So if I would have solved this one using the quadratic formula, what you would have done is you would have had to expand this out completely and put it into standard form. And that standard form is when it's in descending order and set equal to 0. That means you would have had to expand this out. Now remember, you cannot do that by distributing the power. If it is an addition or subtraction, you cannot distribute the square. So what you would have had to have done instead is to multiply this out twice, which means in the next step I would have had to FOIL it. So let me FOIL that v minus 3. That leaves me with first v times v, or v squared. Outside is a negative 3v. Inside is a negative 3v. So combining those together would have given me a negative 6v. And last, negative 3 times negative 3 gives me positive 9. Yeah, carrying down the rest of the problem. Now I need to distribute that 2 through. Gives me a 2v squared. 2 times negative 6 gives me a negative 12v. And 2 times 9 gives me an 18. And then I need to carry down the 90. So if I put this in standard form, that gives me 2v squared minus 12v, and 18 plus 90 is a 108. At this point, you can pick out your a variable, which is 2, your b variable, which is negative 12, and your c variable, which is 108. And you can plug it in your quadratic formula with the correct actual variable that you're trying to solve for, which is this v here. So you would plug those, a, b, and c, into the quadratic equation, which is v equals negative b plus or minus square root of b squared minus 4ac all over 2a. And if you simplified this correctly, you would end up with the same answers that we did up here. So this one is also solvable by the quadratic equation, but if you did it that way, you should probably see that it took me an extreme amount of work to get that done. It took us a lot of steps to get to this point right here, and then it would take us a whole bunch more steps to get all the way through the quadratic equation. So you can see why I definitely prefer the square root method, why we've done it above. However, if you solved it using the quadratic equation, you would have come up to the same answer. Now this is where I'm going to stop this video, and in the next video I'll give you 2 more examples of trying to decide which method is best.